Lesson we talk about what are algebraic expression. Again, an algebraic expression is a math phrase that contains a number, variable, which is a letter, a symbol that could be for a symbol or a letter that could represent any number, and an operation like 5g, 5 times g. So today we're going to learn how to write it. I'm going to give you different sentence structures, and then you're going to substitute those sentences, those words, into symbols, numbers, and operations. But before we do that, let's see if you understood our last lesson. A company charges $6 to make a pattern for an order of T-shirts and $11 for each T-shirt it produces from the pattern. The expression 11n plus 6, or the algebraic expression 11n plus 6, represents the cost of n T-shirts. So the n, this variable or symbol, represents the number of T-shirts they print up. So we need to find the total cost for 5 T-shirts. So I would like you to substitute, evaluate, replace this letter n with 5. What is 11 groups of 5? 55 plus 6 is $61. That is the total cost. So each shirt costs you $11. That's $55. Plus $6 to charge to make the pattern. You know, they had to design it on the computer. So $61. So before we begin, do you know different words associated with different operations? Because if you know your words, your terms, then this activity, this lesson should be easier for you. Like if you see the word sum, that's adding. If you see like sum, total, all kinds of, the word add, plus, more than, those are addition words. So what types of words associated with subtraction? Less than, the word less, the word subtract, the word minus, the word fewer, and I cannot brainstorm any more. I'm sure there are more. What words are associated with multiplication? Product, the word of. Remember, of means multiplication. Like, what's half of 10? 5. 1/2 times 10 over 1 is 10/5. Is 2. Wait, what did I say? What did I just say again? 1/2 of 10. Yeah, 1/2 times 10/1 is 10/2 or 5. Yeah. So product of. I just can't think of any more. I'm sure there are more. And next one, division of. Wait. Per, I mean. Per. Like when you see unit rates or rates, you have to divide. Per. Ratio. Like for example, what is the ratio of dogs to cats? There are 4 dogs, 6 cats. So what is the ratio? So we have to break that down to 2 dogs and 3 cats. So per, ratio, quotient. Those are examples of division words. Groups. Definitely the word groups. And the word each. Each can be, it can depend on the situation. Each could be multiplication, sometimes it could be division. Like for example, I buy 7 apples and each one costs 10 cents each. So I spent 70 cents. So, now let's work on writing algebraic expressions. We're going to teach it through modeling, rectangular model, and then from that we can create the algebraic expression. Some students can skip the drawing, the sketching of the rectangular model, and go straight into writing the algebraic expression with a letter or variable or symbol, with a number, and with an operation. So you can write algebraic expression from word phrases. So here's a word phrase. 17 students more than last year's number. So you circle keywords to help you. Well, 17 students is a keyword. More than is a keyword. And last year's number. That's important. You determine what operation you would use. More than, that means adding. Define the variable by selecting a letter. What letter do you use? So what is the unknown? What do they want us to find out? The unknown, they didn't tell us, is how many students were there last year. So let's use N. N represents last year's students. So now let's draw a model. So you draw a rectangle. These N, these represent last year's student. They are 17 more than this. So let's draw. They are 17 more than this. As you can tell that this rectangle got greater. 17 more than. So it's N plus 17. And that is how you write it as an algebraic expression. I wrote it with a number, a variable, and an operation. Next one. 20 miles less than the O root. So I circle keywords. Operation less than, I know that means subtraction, so I know it will be an operation subtraction. So now I need to find a variable. Let's use R. So what is the unknown? What did they want to know? They didn't tell us. They didn't tell us how many miles is the old root. The old root miles. They didn't tell us that, so it's the unknown. So let's draw it. So here's the old root, or old route, depending on how you say it. And it's 20 less than this. So I need to take away 20 from this. So I need to go back and take away 20 from this. So how would you represent this as an algebraic expression? So here's the root. It's less than 20. R minus 20. Be very, very careful. Every year I see kids who do this. Oh, Mr. Joe, it's 20 minus R. No. Are these the same thing? They are not. They're not commutative, meaning you cannot flip them around and they will give you totally different answers. Because here it says there's 20. So let's look at a picture. Here's the root. Well, here's 20. That's 20 miles. And you're taking away the old root, and whatever you have left is the new root. No. It is, read carefully. You have 20, and it's less than what the old root is. You're taking 20 from how many miles of the old root. That's why R minus 20 is correct, and this one is incorrect. So it's the semantics. It's just reading it, and it's difficulty. It is a little difficult. So you have to read through the phrases and try to figure out where it goes. It's like putting in a puzzle or stuff. So it's 20 less than what the old root miles is. Number 8, $500 divided by the number of men working. So I circle the keywords. What operation is it? Divided. So I know it's going to be division. And let's define the variable. The variables will be M. Let M mean men work. Number of men working. So we have these. So we have $500. So messy. So messy. So we have $500. They are going to divide it by the number of men working. They're going to divide it or break it into little groups. Do we know how many groups are we going to break it into? It doesn't say specifically, so we can't really. So we know we're going to divide it into different groups of men. So it's 500 divided by M, or 500 divided by M. Either one is correct. Either one is an algebraic expression. We were able to translate this English phrase into an algebraic expression phrase, a mathematical phrase. 3 times the number of boys. So 3 times the number of boys. So we circle the key phrases. And what operation? It's times. Now let's define the unknown. What did they not tell us? The number of boys. So B is number of boys. So let's draw this using a rectangular model. Here's a boy, and here's a boy. There's a boy, and it says 3 times this. So we need to triple it. So you could say this could be the answer. B plus B plus B. that is totally acceptable. That's 3 times. Or you can say, how many B's do you see here? 3 groups of B, 3B. Either one is acceptable. They both mean the exact same thing. B plus B plus B is also 3B. What I did is I simplified this expression. I got 3B, and that's going to be in a subsequent lesson. We're going to learn how to simplify expressions. Next one, 20, circle keywords, minus the number of days. So what operation are they telling us to do? Minus. What is the unknown? So we need to find the unknown, the variable. Well, they didn't tell us how many days there are. So let D represent the number of days. So you have 20 minus the number of days. So you have 20, you're taking away the number of days. Could be 1 day, could be 2 days, could be 3 days, could be 19 days. So 20 minus D. Could the answer also be D minus 20? You'll say, it looks the same, it just flipped around. No, it cannot. These are totally different ones. And not saying that you have days and you take away 20 from it. What happens if there's only 2 days? You can't take away 20 days from 2 days. It doesn't make sense. So that's why that cannot be the answer. It has to be this one. You have 20 days, you're taking away days from that 20. Number 11. 4 more than twice the number of machines available. So I circle keywords. Operation I can see is more than and twice. I think there are double operations here. Ooh, I think this is harder. More than means adding. Twice means multiplication. So what is the unknown? What did they not tell us? They didn't tell us the number of machines available. So what letter you would like to use? I like to use M. The number of machines available. So we have twice the number, 4 more than. So we have machines and machines. So we have twice the number of machines and 4 more than. So we have 4 more than twice the number of machines. So you could say the answer is M plus 4. You can also even write it as 2M plus 4. Yeah. So either one is correct. So it's 4 more than twice the number of machines. It's there's 2 machines. An electrician charges $11 per hour and spends $20 a day on gasoline. So he charges $11 per hour and spends $20 a day. So what is the operation? So per $11 per hour. Some of you say, oh, it's dividing. Could be. Also, it could be multiplication. Per could be because like every day every hour he charges $11. So what is the unknown? What did that tell us? The number of hours he works. He works $11 per hour. How many hours was that? I don't know. And he spends $20 a day on gasoline. So electrician charges $11 per hour and spends $20 on gasoline. So let H represent hours. Let H represent hours. So we have 11. Oh wait. H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then he charges $11 per hour, and then he spends. When he spends, is that adding or subtracting? Subtracting. He spends $20 a day. So we need to take away 20 from this. So how would you write this? How many H's do you have? 11 H's. So it's $11 an hour. He spends $20. So this is the algebraic expression. So he makes $11 depending on the number of hours, and he spends $20. And last but not least, Mr. Guang or Mrs. Guang purchased 4 airline tickets to Florida. She will also pay, so she bought 4 airline tickets. She will pay a fee of $50 for an extra piece of luggage. Define a variable and write an expression to represent her total cost of flying. So what did they not tell us here? I didn't think they tell us what is the unknown. I don't think they told us how much the ticket cost. So T is ticket cost. They forgot to tell us how much the ticket costs. So Mrs. Guam purchased 4 airline tickets. So she purchased 1 airline ticket, 2 airline ticket, 3 airline ticket, 4 airline ticket. Then she paid $55 for an extra piece of luggage. So how would you write this as an algebraic expression? How many, you could write T plus T plus T plus T plus 55. Or we can simplify this expression. How many T's do you see here? 4 T's plus 55. So she bought 4 luggages, for 4 tickets I mean, and we don't know the number, we don't know how much she spent on a ticket. So she bought 4 tickets at this cost plus $55. And that will tell her her final cost. For example, if the ticket costs $100, each ticket costs $100, and she bought 4 of them, 100, 100, 100, 100, that's $455. If each ticket costs $200, 200, 200, 200, 200, that's $855. So what we've learned is, we learned how to get English phrases, and we learned how to turn it into algebraic expression. So an algebraic expression has a number, a variable, and operation. So what you do is you circle keywords. You have to figure out which operation is it talking about. And from that, you can either draw pictures. Some people do not need to draw pictures. Some people can formulate it in their brain and write out a algebraic expression.